So when we have an f prime, right, the relationship between f prime and f, or the derivative and the original function. Okay, so if we know that the derivative, remember derivative means slope, so f prime means slope. Okay, if the slope of our derivative is 0, okay, that means that we're at a possible, right, that means that the tangent line, or the slope of the tangent line to the graph of f is horizontal. Right, in order for our slope to be 0, we either need to be at the bottom of a minimum or at the top of a relative maximum. Right, these are the two places on our graphs where your slope is 0. Okay, your first derivative, your f prime, is going to be 0. Okay, and then we had talked about if your slope is positive, right? What happens if we have a positive slope? Okay, that means that f of x is increasing. Right? The y values are getting larger on the actual graph of x. And if your slope is decreasing, right, your slope is negative, we have a negative slope, that means that the y values on f are decreasing. Okay, on those intervals, right, they're always on open intervals for whenever it happens to be increasing or decreasing. So make sure when we're writing an interval that we're always using, right, parentheses, not brackets. Okay, because at that point is actually going to be 0. So that was what's happening at the top or at the bottom of this graph. Okay, and now here are some important things to be able to distinguish. What happens if your slope changes from positive to negative? Okay, so if we're looking at my little sketch up here, right, right, all these, the graph is increasing, so our slope is positive. And then over here, your graph is decreasing. So what do we have if we have increasing on the left and then decreasing on the right? F of x has a relative maximum. Okay, at that point where it changes, right? And this point where it changes, right, that's going to be an x value. For our derivative, that's where the graph is going to cross the x-axis, our f prime graph. Okay, so if our slope changes from positive to negative, we have reached a maximum point. And the other way, if the slope goes from negative to positive, we have reached a minimum. Okay, that means f of x has a minimum, a relative minimum at that point. Okay, so we are interpreting our graphs of f and f prime to see what is happening with the relation. So if we're looking at f prime, what is happening with f? And if we're looking at f, what is happening with f prime? Okay, and are we able to find these potential values? So let's use that information in our graph here. Okay, this is the graph of f prime. This is the graph of f, sorry, looking at the lower corner. Right, down here it says possible graph of f prime. So this is going to be where we sketch our other problem, our answer, right? If this is our f graph, what does our answer look like? Okay, so the first thing we'll identify is where are the zeros. Okay, so we have a 0 here, right? This would be a 0 at 1, 2, 3, negative 4. So over here on our graph of f prime, we're going to have a 0 at negative 4. Okay, we also have another 0 slope at positive 1. So you put on the f prime graph an x-intercept at positive 1. And we have one more 0 at, looks like, positive 5. So those are the zeros of your graph, right? It's where your f is a relative max or relative min, right? It's where the slopes of your f are 0. And that happens at a maximum and at a minimum. So now we have to identify where is our f prime graph above the x-axis. Okay, where are our slopes positive? Well, your slopes are positive when our graph is increasing, right? So if our function is increasing, right, here's an increasing part of our function, that means the slope of the derivative, right, f prime, is going to be above the y-axis. So if we come over here to our slope graph, right, the graph is going to be above the y-axis because our slopes are positive. Right, and I don't know how steep this line is or whatever, but I know that it's going to be above the y-axis because that's where f primes are positive. And then I am decreasing, right, these are all decreasing intervals from, looks like -4 to +1. So I know that between these 2 points, -4 and +1, on this interval, my f prime will be below the x-axis. And I don't know how far down it goes, right? I don't know exactly what that point down there is at the moment. But I know that because my graph is decreasing, that my slope function has to be below the x-axis. Okay, so back to our graph. Now we are once again increasing. So our graph is going up, which means our prime, right, our f prime is going to be above the x-axis between this interval of +1 and +5. And lastly, our graph is going to be decreasing, so it's going to be below the x-axis everywhere else after +5. Okay, so this is once again a possible graph of f prime. I don't know what those relative maxes and mins are. I'm just putting them on there. So wherever our f graph is increasing, our f prime is above the x-axis, right? Wherever our f graph has a max or a min, our f prime has a 0. And whenever our f is decreasing, our f prime is below the y-axis. Okay, so it's important to know so that when we actually get to doing some math problems, which we're going to do in a second, right, how can we interpret the math problems with the graphs of f prime and f? So here is a problem where we're given the function, the graph of f. Remember what it says, this is the graph of f. Okay? So this is our f graph, and we're going to answer all these questions about f prime. It looks exactly like the one we had a second ago, thank goodness, so we can apply what we've learned. Number 1 says approximate the value of f prime at 4. Okay, so when it says approximate, that wants you to use the difference quotient. Sorry, not the difference quotient, but the average rate of change for +4. So let's see if I can zoom in here. Here is +4, so we're talking about this point right there, maybe something like that. So we can use our best approximation, and maybe this is going to be the tangent line, something like that, maybe-ish. Something. So we're going to take a point to the right of that +4, and we're going to take a point to the left of +4. So this looks like the point 5, 1, 2, 3, 4, 5, 6. And this looks like the point 3, 0. And we're going to use these 2 points to approximate the slope of that line. When it says approximate, it wants you to do this. Okay, and this is what calculus needs to see when it wants you to approximate. So we're going to take f of 5 minus f of 3 over 5 minus 3, right? That's a pretty good approximation of the value at 4. Okay, the slope of the line at 4. Now, from our graph, we got that f of 5 was 6 and f of 3 was 0. So we plug in 6 and 0 because those are the y values at these respective x's. And we get 6 over 2. Sorry, 6 over 2. So approximately, my graph has a value of 3. So let's do this for real. So f prime at 4 is approximately. Okay, let's be very specific, and this is what I want you to do on your FRQs, right? Be specific about what we're talking about. We are talking about the slope of the line at positive 4. And then this is the equation of that line. Okay, our next question says, at what values of x is f prime equal to 0? Okay, so looking at the graph, it looks like we have, once again, at negative 4, at positive 1, and at positive, is that positive 5? 1, 2, 3, 4, 5. Yes, positive 5. Okay, so we write f prime of x equals 0 at x equals negative 4, positive 1, and positive 5 because the slope of the horizontal what should we call this? The tangent line of f is 0. Okay, horizontal tangent. Okay, so just write down what you see. The slope of the tangent line is 0. Right, so we're using the graph of f, and we are interpreting it to answer a question about f prime. Okay, so on what open intervals is f prime of x less than 0? So if we're looking at our other thing, it's less than 0 when the graph of f is decreasing. So we're going to come over here and look and see when is our graph decreasing. It looks like it's decreasing between negative 4 and 1, as well as 5 to infinity, because these are the intervals. Remember, they're open intervals, so we're always going to use parentheses from negative 4 to positive 1. So we write f prime of x is less than 0 on negative 4 to 1 and 5 to infinity, because f of x is doing what? Decreasing. Okay, and that's all we have to write. Yeah, so this one, f prime of x, is greater than 0 on the interval from negative infinity to positive 4. Oops, negative 4. And then from 1 to 5, because f of x is increasing. Okay, so we're taking an answer about f prime based upon the graph of f. So where f of x is increasing, f prime is positive. Where f of x is decreasing, f prime is negative. And here we have some bigger questions. At what value of x does f prime go from being below the x-axis to above the x-axis? Okay, so we have at x equals 1, because that's where the f changes from decreasing to increasing. Okay, that means your f prime goes from being negative to positive. And similarly for the next part, where does it go from being above the x-axis to below the x-axis? Okay, so we're going to answer this question by using complete sentences. F prime will go from this to this at x equals negative 4 and 5, because f changes from increasing to decreasing. Okay, we are answering questions about f prime with an answer related to f. Okay, so we are answering an f prime question by relating it back to f. Okay, that's how you're going to justify your answer. But because f is changing from increasing to decreasing, or from before, x is changing from decreasing to increasing.